So today we're going to look at composition and inverses of functions. So composition of functions has this notation. Okay, they both mean the same things, and you'll see problems presented to you in both ways. You just have to remember that they both mean the same thing. So what this means is that I'm going to take the inside function, in this case g of x, and I'm going to plug it in for all the x values in my f function. Now, we can see it as f of g of x, that's how we say it, or it can be flipped around and be g of f of x, okay? But the important thing to remember is we take the inside function and we plug it into the outside function. So, looking at example 1, f of g of x. I always like to just rewrite it this way because it makes more sense to me. Because again, I see my inside function, and I'm going to plug it into the outside function. So I'm taking g of x, and anywhere I see an x in f, I'm going to plug in 2x plus 1. So that would look like this. 2x plus 1 squared minus 3 times 2x plus 1, and then plus 8. So 2x plus 1 squared. Thinking back to your algebra days, right? That means I have it written twice. And let's just rewrite the whole thing. So 2x plus 1 times 2x plus 1, I'm going to FOIL. So first times first, be 4x squared. Outside, 2x plus 1. Inside, 1 times 2x. So plus 2x, and then last, plus 1. The negative 3 I'm going to have to distribute, so minus 6x minus 3, and then I don't want to forget that plus 8. Now I'm just going to go through and combine like terms. So there's no other x squared. I see that I have plus 2x minus 6x. So that's 4x minus 6x, which gives me minus 2x. And then I have 1 minus 3 plus 8, which gives me positive 6. So there is my answer. Now, it also asks me to find the domain. So looking at my function, this is a quadratic. And quadratics have domain of all real numbers. Okay. Now, next example. So I have my two functions. Now, this time it's asking me to find f of g of x and g of f of x, and then to find their domains. So let's do the first one, f of g of x. So f of g of x. So I'm taking g of x and plugging it into f. So I'm taking 5 over x minus 1 and replacing the x's in f of x with 5 over x minus 1. So that would look like this. So there's the new numerator, all over x minus 1 plus 2. Now, if you remember from your Algebra 2 days, when I have fractions inside of fractions, right? So complex fractions, I want to multiply everything by my least common denominator, or least common divisor. So in this case, it would be x minus 1. So I'm going to multiply everything inside my fraction by x minus 1. So that would look like that. And would give me, so in the numerator, the x minus 1s would cancel and I'd be left with 5. The denominator, 5 over x minus 1 times x minus 1, the x minus 1s would cancel and I'd be left with 5. And then 2 times x minus 1. So I just have to simplify that denominator a little bit. Distribute the 2. Minus 2, sorry. And then combine my like terms. So I would get 2x plus 3. So there's my new function. Now it asks me to find the domain of this. So with rational functions, my denominator can never equal 0. So we want to figure out the x value that would make the denominator 0. So setting the denominator equal to 0, subtract 3 divided by 2, I would get negative 3 over 2. So my domain, all of my x values except negative 3 over 2. Now going the other way. So this time we have g of f of x. So I'm taking f of x and plugging it into g. So I'm taking this and I'm plugging it in just into that x. That's the only x in g. So that would look like this. X over x plus 2 minus 1. Again, I have fractions inside of my fraction, so I want to find that least common denominator, which would be x plus 2. Multiply everything by x plus 2. So on top, I would have 5 times x plus 2. Denominator, the x plus 2's would cancel that first part, so I'd be left with just the x, and then minus 1 x plus 2. Distributing on the top and the bottom, I would get 5x plus 10, x minus 2. So the x's here would cancel, and I would have 5x plus 10 all over negative 2. And I'm going to go ahead and just rewrite that. So there would be my answer. Now, to find the domain, right? Think about the function type. This is a linear function. Linear functions go on forever in both directions. So my domain, be all reals. Okay, so that's composition. Now, let's talk about inverses. So, inverse functions are two functions that sort of cancel each other out. Now, notation is a big thing here. F to the negative 1 or f to the negative 1 of x. Okay, when we're describing the inverse, we have to make sure we say f to the negative 1 of x. Okay. Now, at the end of this video, we'll talk about actually finding the inverse given a function. And the way we do that is to switch my x's and y's. Okay. So if I'm switching the x's and y's of my original function, that means that the domain and range are also going to be flipped. So the domain of f is the range of my inverse, and likewise, the range of f is the domain of my inverse. So the composition of f and its inverse is x. This is another thing we're going to look at here in a little bit. So what that means is f of f to the negative 1 of x. So when I plug my inverse into my original, I'm going to get x. And going the other way, f to the negative 1 of f of x. If I plug my original into the inverse, I'm going to get x. So that's how we determine if two functions are inverses of each other. And we'll look at problems like that in a minute. A function and its inverse are symmetric with respect to the line y equals x. Now here are some vocab terms for you. A function is one-to-one. That's a function in which different inputs, so different x values, never correspond to the same outputs. Okay, so if I have repeated y values, it's not one-to-one. Now, if my function is one-to-one, then the inverse is also going to be a function. And sometimes we'll have to restrict domains. Oh, sorry. Now, the way we check to see if our inverse is going to be a function, all right? So I'm given the graph of my function, f of x, and I'm going to do the horizontal line test. Okay? If it passes the horizontal line test, then it is one-to-one, and the inverse will be a function, okay? So again, going back to the composition of f and its inverse is x, two functions are inverses if we can show that plugging them into each other gives me x. So before we look at that, let's first just find the inverse given some ordered pairs, and then identify if the function is 1-to-1. So, curly bracket, I'm going to flip x and y. So my ordered pair instead of -2, 5 would be 5, -2, 2, -1, 1, 0, 2, 1, 5, 2. Now, is my function, my original function, okay, the original ordered pairs, is that 1-to-1? So I want to look and make sure that I have no repeated y's, right? I can't have different inputs corresponding to the same outputs. And when I look here, I see that I have repeating y's. So this would not be 1-to-1 because we have repeated y's. And that also tells me that my inverse is not a function, which we can also see because I have repeated x values. Remember, repeated x values makes my graph or info not a function, okay? All right, let's look at the next one. Inverse. So I want to flip x and y. -11, -2, -4, -1, -3, 0, -2, 1, 5, 2. Looking at my original function, are there any repeated y's? I look, everything is different, so this would be 1-to-1, which means my inverse is a function. And again, if we looked at my inverse, I see that I have no repeated x values, so that's another way you can tell the inverse is a function. All right, now, looking at my graphs, and we want to determine if their inverses will be functions. So again, I'm going to do the horizontal line test. So draw some horizontal lines. Only hits my graph one time, so the inverse would be a function. B, draw a horizontal line. It hits in multiple places. So no, my inverse would not be a function. It's not 1-to-1. Next one, same thing. Hits in 2 spots. So this is not 1-to-1, so the inverse would not be a function. All right, now, we're going to use composition to determine if the functions are inverses. So this has 2 parts. I need to check f of g of x, and I need to check g of f of x. If they both cancel out to just being x, then they are inverses. So let's find f of g of x first, and we'll do that in blue. So I'm taking g of x, and I'm plugging it in to the x and f of x. So 2 times 1/2 x plus 5 minus 5. So the 2 and the 1/2 cancel. I get x plus 5 minus 5. The 5's cancel, and I'm left with x. So I'm halfway there. Now I need to check the other way. So I'm going to take f of x, and I'm going to plug it in to g. So 1/2, 2x minus 5 plus 5. 5's cancel. The 1/2 and the 2 cancel, and I'm left with x. So since my 2 compositions work themselves down to x, then these are inverses of each other. So we say they are inverses. And that would be my answer, that they are inverses. That's what the question's asking me to find. Okay, so you have to make sure you state that. Okay. All right, let's look at number 5. So this is probably the toughest of the problems we'll look at today. So again, use composition to determine if the functions are inverses. So I'm going to find f of g of x first. So let's do that in blue. So I'm taking g of x and plugging it in to x. So I would have 2x plus 4 over x minus 1 plus 4. So there's my numerator. Denominator, 2x plus 4, x minus 1 minus 2. So finding that LCD, it would be x minus 1. So multiply everything by x minus 1. So the x minus 1s would cancel in that first part. So I would have 2x plus 4. 4 times x minus 1. All over, again, the x minus 1s would cancel. So I would have 2x plus 4. And then negative 2 times x minus 1. Distribute on top and bottom. 2x plus 4 plus 4x minus 4. 2x plus 4 minus 2x plus 2. Combine your like terms. So I would have 6x, the 4's would cancel. 2x and the negative 2x would cancel. So that would leave me with x. So again, I'm halfway there. Now let's do the same thing, but the other way. So I want to do g of f of x. I'm going to do this in purple. So this time I'm taking this and plugging it in here and here. So on top, I would have 2 times x plus 4 over x minus 2 plus 4. On bottom, x plus 4 over x minus 2 minus 1. So again, that LCD this time would be x minus 2. So multiplying everything by x minus 2, I would get that top first piece, the x minus 2's would cancel, and I'd be left with 2 and x plus 4. 4 times x minus 2 on bottom. The x minus 2's would cancel in that first part, and then negative 1 times x minus 2. Doing my distributing everywhere, get 2x plus 8 plus 4x minus 8, x plus 4 minus x plus 2. So on top, 2x plus 4x is 6x. The 8's would cancel. On the bottom, the x's would cancel, and I'd be left with 6, which simplifies down to x. So since they are both equal to x, my answer, they are inverses. Okay. All right, the last little bit of this video, we are going to actually find the inverse given a function. So the way we do this, step 1, switch x and y. Now, if it's not set up as y equals already, we're going to replace f of x or g of x, whatever it is, with y equals. Then once I switch, I just resolve for y. So in this case, this is f of x equals, so I'm going to switch that and make it y equals x squared minus 6. Now, switching x and y, I would have x equals y squared minus 6. And now I just want to make it y equals again. So I'm going to add the 6 over. So I'd have y squared equals x plus 6. To get rid of the square, I am going to square root both sides. So I get y equals the square root of x plus 6. Now, that is not our final answer. Remember when we were talking about what inverses were, we talked about notation. So my final step to get this question 100% correct, I have to put it in inverse notation. So instead of y equals, my function's f, right? So this would be f to the negative 1 of x equals the square root of x plus 6. I have to denote that, hey, this is my inverse of f of x. Okay, so don't forget that final step. All right, last problem. This one's a little bit tougher. So again, it's g of x, so I want to make it y equals. Switch your x's and y's. So I'm going to have x equals y plus 2 over 2y minus 1. Now, I need to break up that fraction. So I'm going to multiply the denominator to both sides. So those cancel. and I have x times 2y minus 1, y plus 2. So I want to distribute the x. So I get 2xy minus x equals y plus 2. Now, the issue here, right, I need to make it y equals again, but I see that I have two y's, right? I have the y with the 2xy, and then I have the y from the y plus 2. The way we're going to deal with this is I want to get everything that has a y to one side and everything that doesn't to the other. That way I can factor out the y, and then it brings me down to just the one y that I need. So I need to move this to that side, so the y's are all over there, and I need to move that to that side because it doesn't have a y. So I would subtract the y and add the x, which would leave me with 2xy minus y equals x plus 2. So again, now that I have the y's on the same side, both of my terms have y, so I want to factor that out. So pulling that y out to the front, I would have 2x minus 1 left on the inside. Now my final step, to get this to be y equals, I would have to divide the 2x minus 1 off, which would give me x plus 2 over 2x minus 1. But again, that's not my final answer. I have to put this in inverse notation. So my function is g of x, so I'd have g to the negative 1 of x equals x plus 2 over 2x minus 1. And that would be my final answer.